Hello, everyone. My name is Micaela RODRÍGUEZ, and I'm an Argentinian paleontologist. I've got my PhD at the University of La Plata and the University of Lyon. And currently, I'm doing my postdoc at the Institute of Biobiology and Geology Investigations in Rio Negro, Argentina. I'm mainly interested in calcareous nanofossils from the early to middle Jurassic. So what I wanted to share with you is some of the results that I got during my PhD. So let's start with a bit of context. Most of the information that we know about calcareous nanofossils from the early to middle Jurassic comes from the northern hemisphere, particularly from the western Tethys. And if we look at the southern hemisphere, we can see there are very few localities. Actually, from the southern western Gondwana, we only have two localities recording nanos from this age. One is the Andean Basin in Chile, and the other one is the Neuquén Basin in Argentina. As you can see in the graph, most of the contributions comes from the North Hemisphere. 70% comes from Europe. And in comparison, we know very little about the South Hemisphere. Also, we have to highlight that the Western Tethys account more than 20 biostratigraphic schemes, and the South Hemisphere has none. So, as I was telling you, the Neuquén Basin, as you can see in the map, is located in west central Argentina. It covers a huge extension. It records almost 70,000 meters of continental and marine sediments. And it records also the first transgression from the Pacific Ocean into the continent. This transgression is recorded in the Cuyo group, in the units as like Los Moches Formation and Sierra Chacaico. So what we did is to go to the field, to the outcrops, make a sampling for calcareous nanofossils and analyze them. And we were able to identify 22 species distributed in 6 families. This record was very rich, very diverse, and very well preserved. And while we were looking for the literature about these species, we found that some of them have a very complex taxonomic history. As an example, we can talk about Crepidolithus crucifer. This species was introduced in 1969 by Prince, but it was nomen nullo. Finally, it was validated by Ruth and collaborators in 1973. But the image that the authors used was a SEM image in proximal view. A year later, in 1974, Barnard and Hay also presented an image of this species, but in a distal view. After comments and goings, in 1987, Bound put in junior synonym this species with Crepidolithus crassus. And only in 2010, by means of biometry, Fraguas and Herba were able to differentiate these two species. So actually, we can say that the first picture of this species is the one presented by Barnard and Hay in 1974. We also were able to identify different morphotypes. For example, we identified the early morphotype of Lotaryngius barossi. And also, we make emendations for the genus Lotaryngius and for the species Lotaryngius barossi. We also recorded first occurrences in Argentina or the Southern Hemisphere of many species, as the ones that you can see in the screen. And also, we recorded a big morphotype of Similiscutum finchi, which actually, nowadays, is a new species, Similiscutum giganteum. Last but not least, checking the literature, we have seen that there were similarities in between the section that we serve in Argentina, called Hematoasto 1, and some sections from the Western Tethys. In Argentina, we recorded marked species from the early Pliensbachian, but also some species that typically were known as Tethyan species. So the only explanation that we found to have a connection in between these two very far apart places on the planet, it's by means of the Hispanic corridor, at least from the early Pliensbachian. So I hope you enjoy this small presentation and don't miss the next NannoTalk. Bye.